what we're taking a look at here is graphing quadratics that are going to be in vertex form. Vertex form ends up looking like this. It's not in standard form where we had ax squared plus bx plus c. It's not in intercept form where we're multiplying two binomials. Instead, what we're going to end up looking at is something that kind of looks, again, like our absolute value equations. And we're going to end up going through and graphing this very similarly to how we ended up graphing absolute value equations. Because what we're told in vertex form, we have x minus h squared plus k. Our vertex ends up being the point h comma k. So that's our vertex, and we can identify that right away just looking at this form structurally. So what I have is negative x minus 3 squared plus 2. What that's telling me right off the bat is that my vertex is going to be the point 3 comma 2. 3 comma 2. That tells us just straight from vertex form, and this is something that we had went through and discovered through that Desmos activity. This graph has shifted 3 to the right, and it's gone 2 up, so my vertex has shifted from 0, 0 to 3, 2. So I can go ahead and plot that right here, 3 comma 2. Alright, and now our process from here is very similar to that in standard form. We have to go through and find 2 points, whether they're to the left of the vertex or to the right of the vertex. For example, finding x equals 2 and x equals 1, or plug in x equals 4 and x equals 5 to actually go through and complete the rest of this quadratic. So what we'll choose is x equals 2 and x equals 1. We're going to take x equals 2 and x equals 1 and plug those two into our original function. So we're going to evaluate f of 2 and we're going to evaluate f of 1. When we evaluate f of 2, we would have negative 2 minus 3 squared plus 2, and we would go through and just use PEMDAS to simplify this. Inside the parentheses first, we would have negative 1. Negative 1 squared should be positive 1. Negative times positive 1 would be negative 1 plus 2, which ultimately gives me a positive 1. So what that tells me, oh, didn't realize I was drifting off the page there. When I plug in 2, I should have a y value of 1. And I'm really going to go through and do the same exact thing with x equaling 1. I'm going to plug in 1 anywhere I see an x, which would be right there, and I'm going to go through this same process of order of operations. Negative 2 squared should be positive 4. Negative times 4 is negative 4 plus 2, which ends up giving me negative 2. So I should have the point positive 1 comma negative 2. So I'm going to take those 2 points and graph them on my graph. 2, 1, 2 to the right, 1 up. Next point, 1 over, and 2 down. And I can go ahead and label those points as well. 2, 1, and over here I have 1, negative 2. And just like in standard form, we can go through and sketch our parabola now, like this. And we know, because of the shape, that we're going to have symmetry across the vertex, across our axis of symmetry. So we should be able to go through and finish off the parabola. Now, if you went the other way, you should have found the points 4, 1 and 5, negative 2, because these points are both 1 away from the vertex in terms of x. This is 1 away, this is 1 away. Their y value should be the same. These two are 2 values away from the axis of symmetry, so their y values should be the same. That kind of relates back to our intercept form, where we know that the vertex should be in the middle of any 2 points that have the same y value. These 2 points have the same y value. Their vertex then should be directly in the middle, which it is in terms of the x values. Now again, just like we had done before, we're looking at the minimum or the maximum value. Here, we could even identify from the beginning that we have a negative in the front, so our graph should open down. So by looking at the minimum and the maximum values, we should be able to identify a maximum, which we can right here, being 3, 2. Our vertex ends up being a maximum. In this case, our minimums would end up being negative infinity, and there's really no point that we can identify, just because these are going to continue to go on forever and ever and ever. in the negative infinity direction.